Welcome back, class. We just finished talking about physical geography and the requirements and necessity for field work and observations. I went ahead and showed you this picture right here about me collecting and mapping areas of Alaska, remote areas of Alaska. But you know, the capabilities and requirements of physical geography really forces geographers to go out into the field, which I think is a huge draw for the discipline. It's one of the reasons why I became a geography major. As we talked about in the beginning, we talked about what is geography, and I asked you to write down in your notes how you would define it. And I went over how, I myself, based on atmospheric science, how I would define physical geography. And so just be aware that one of the weekly discussions will be how you define physical geography. Now, one thing to talk about physical geography is if we look at it from an environment standpoint, it's defined as the complex of physical, chemical, and biotic factors such as climate, soil, and living that act upon an organism or an ecological community that ultimately defines its form of survival. Then that's one of the definitions. Now, if we look at the connections here of what is the connection between environment and physical geography? Well, the connections is that it's both very similar to cultural and physical geography in that it provides an important background in the study of the environment. Okay, so physical geography provides an important background in the study of the environment as it pertains to these four spheres that we already defined, but then also how it connects with the culture. So we have this interconnection between the environment, which we went ahead and defined, what is the environment? It's this interconnection of physical, biotic organisms that all work together and how that relates to physical geography. So when we talk about physical geography, we need to consider it as a foundation of many different disciplines, as we talked about. Now, in providing a little bit more history and background, we can start by talking about the way that people think about things over time. Okay, now I understand we're incorporating an element of cultural geography in here, but people are the mechanisms in which they collect information for physical geography. So it's very important for us to get into the minds of how people thought about the things during certain periods of time. So starting back to the 1850s to 1950s, we can look at major concepts. Now, during this time, physical geography was looked at as having four main ideas that had a strong influence on physical geography as a discipline. The first one was looking at physical geography through a uniformitarianism approach. The second one is looking at physical geography through evolution, and that was highlighted with Charles Darwin. And looking at physical geography as an idea of exploration and surveying, okay, so mapping. And then looking at physical geography on the component of conservation, so applying a cultural element to it. And we'll talk about all four of these influences on the discipline right now. So when we look at uniformitarianism, okay, this is the assumption that the same natural laws and processes that operate in the universe now have always operated in the universe in the past and apply everywhere in the universe. Okay, so this is a huge concept for my discipline and research in atmospheric science. The idea that atmospheric rivers exist all around the world, and the same fundamental elements that we experience in the Pacific Ocean are similar to what is experienced in the Pacific Ocean in the Southern Hemisphere or the Atlantic Ocean across the United States. So these are principal elements that we use for geology. So the key principles that use to that require a volcano to become active exist everywhere on the Earth's surface. And this is one of the known elements that was added to the discipline of geography. So for example, the known components that allowed for these sandstone layers to build up one layer upon one layer over time And then notice that curviness that looks at the bottom of the picture here of the strata. It looks like it's been pushed up. Now we're involving tectonic action. Okay, so we can assume that the same elements that cause the plates to move cause the same uplifting for these layers to have this kind of interruption in the strata. Okay, and that's an example of uniformitarianism. We can look into the discipline of evolution. So this was introduced in the 1859 that suggested that natural selection determined which individuals would pass on their genetic traits to future generations. Now, this was identified by Charles Darwin, who wrote The Origin of Species. Now, Charles Darwin used many different geographers' resources to come to conclusion of the origin of species. One importantly was Alexander von Humboldt. And so I have a video that you guys will watch this week about Alexander von Humboldt. We also had the element of exploration and surveying. So at this period of time, much of the world had not been explored before the 1900s. And so this was during a period of massive exploration, massive field collection, observation, and mapping. And then we had the elements of conservation, which was somewhat of a new terminology to even be addressed. And so in the 1850s, there was a major concern about the environment. So George Perkin Marsh was one of the first to write about conservation. He wrote a book called Man and Nature, and also wrote a book about physical geography. Now, the major concern was that there was a lot of deforestation going on. There was a lot of water contamination. There was a huge draw of people moving to urban areas due to environmental conditions and changes that existed out in rural areas. So lots of people moving to an area, lots of growth, and no real way to improve the quality of life or even have like the understanding of conservation, and that there needs to be smart planning of towns. Maybe we should not cut down all the trees. That's going to influence runoff. That's going to influence our groundwater, and so on and so forth. So this element of conservation was one of the elements. So how have we changed the way we think? So let's talk a little bit about that. So after the 1950s, the following two forces largely determined the nature of physical geography. Okay, and this was the Quantitative Revolution and then the human-land relationship. So the Quantitative Revolution was the measurement of physical geographic things. Okay, so quantitative. When you think of quantitative, you think of quantity. When you think of quantity, you're thinking of numbers. So it's the measurement of things. So during this period of time, we were actively going out, measuring, taking samples, observations of everything. So to line up with physical geography, we were out there, collecting temperature data, climate data, water quality data, measuring our glaciers. So this was identified as the Quantitative Revolution. Measurements allow for mapping, modeling, statistics, mathematics, and hypothesis to develop and evolve as a result of collecting data. The also element of human and land relationships. So really the observation of what humans are doing on the landscape was becoming more obvious. And more importantly, how can we control this observation? And as a result, fields such as environmental geography, conservation geography, natural resources stemmed out of this idea that we need to be very sensitive to how humans have an impact on the land. We have a direct relationship, but we now need to be aware. And so looking at places where there's high population that still have trash and human waste that are in open ditches to this day, also areas around the world where we're clear cutting forests and we're exposing soil that should not have direct sunlight. As a result of that soil getting direct sunlight, the water can no longer percolate through the ground. Okay, and so understanding this human-land relationship was huge and is still a large component. Also looking at major disasters around the world and, highlighting Hurricane Sandy, in the fact that there was observations of humans on landscapes, and it becomes obvious that, we have a lot of population on various coastal regions. When a disaster occurs, such as Hurricane Sandy, Hurricane Katrina, all of the earthquakes that take place in highly populated areas, we see a direct link, this impact of cultural and humans associated with the physical geography. And so these natural disasters allow for us to look at the impact, identify natural hazards, but also identify how humans and the earth can interact in this kind of environmental setting. So we can see here's some pictures of Hurricane Sandy. So where we have homes that are built right on the coast, on sandy stilts, are going to be an area of high impact when a large mid-latitude hurricane hits the coast. Now, all of these elements can be taken in the form of observations, okay, and how something such as a hurricane can influence urbanization, how it can impact a certain situation. So especially with the Olympics in the news, we look at urbanization and you look at all the different regions and neighborhoods where there's houses built on top of houses and people are living right on top of each other. Now, when we look at physical geography and we look at the future of physical geography, this is what excites me. The study of humans as we introduce these environmental problems. Now, how do we manage these problems? We identify these problems, we collect data on these problems. Now, can we as a civilization manage and solve the problems that we have created by not listening and not respecting our environment? So, for example, what's going to happen if all of the world's glaciers, which act as a natural reserve for fresh water, melt? How can we change that? How can we solve a problem? Is there a chance that we can solve a problem? There's all of these issues that are in the news now that is going to be relevant to your life and your children's lives. And it all stems back to physical geography, this interaction of humans, this interaction between the environment, and the interaction between all of the spheres that we talked about. So when we talk about the future of physical geography, we need to talk about remote sensing, and we'll talk about mapping and remote sensing, quite a bit throughout this semester. But we have these tools that allow us to see, observe, collect information from afar. So using remote sensing, we're able to look at, vegetation, the health of vegetation. We're able to look at plumes of algae, toxic algae in various waterways. And so it's this element that really expands the field of geography. And that's why we have classes such as GIS, Geographic Information Systems, that is in the house of geography. So when we talk about geographic information systems, this is the element that encompasses everything that we just talked about with physical geography, but applies the sense of mapping to it. So I'll share a video for you guys about what is GIS that you can watch on your own time. GIS has taken off in the form of celebrations, allowing students to participate in annual celebrations. This is a local GIS day that I've been a part of hosting over the last 3 years now. And it's an opportunity for students to come together and learn more about geography and mapping. And it's an opportunity for folks in the profession to share what they have to offer. Now, so we're coming to an end of our 15-minute block. The next session, so there will be 4 for this week, we'll talk about the scientific method.